Hello everyone, my name is Molly and I'm here to go over a problem that was in our Unit 4 section, Solving Systems. Let's begin. The problem was work with your team, in this case I am your team for today, to find two different ways to solve x minus 2 squared plus 4 equals 2x plus 3. Be sure to explain the logic of each of your methods and show that the solutions are correct. Well, this may seem a little wordy, but the main objective here is to find two different ways to solve x minus 2 squared plus 4 equals 2x plus 3. But before doing so, let's figure out what's really in this problem. There are two different types of functions in this problem. One is a quadratic function, which is x minus 2 squared plus 4. You can tell right off the bat that this is a parabola because there's a square. And looking at it more closely, you can tell that it is in vertex form because there's an a, h, and k. I color-coded the a's, h's, and k's for you. The next function is a linear function, 2x plus 3. This linear function is in y equals mx plus b form. So now that we know what's in our problem, we can start solving. So right away I can think of two different approaches on how to solve these functions. One is algebraically and the next is graphically, so we can move these out of our way for workspace, but we will use those as references. So let's start off solving algebraically. Now here is our initial equation or initial problem. Now let's expand this part here so we really know what we're dealing with. So that will expand to x minus 2 times x minus 2 plus 4 equals 2x plus 3. Now this polynomial right here, let's work with this so it'll look more standard. So by doing that, we will use the FOIL method. So x times x equals x squared, x times negative 2 equals negative 2x, negative 2 times x equals negative 2x, and negative 2 times negative 2 equals positive 4. Now this section here we can just bring down because that'll just be the same. So now let's look at what we have. We have many like terms, but we want to combine all these like terms. So let's focus on the blue. 4 and 4 want to be together, so they want to combine, so that will turn into an 8. And this 3 over here wants to be on the same side as the 8, so we will subtract 3 from both sides, and the following will be x squared minus 2x plus 5, because 8 minus 3 is 5, equals 2x. Now we still have some like terms that consist of x, so let's combine all of those. Negative 2x minus 2x equals negative 4x, and let's move this 2x on the other side, so subtract 2x from both sides, and we will get x squared minus 6x plus 5 equals 0. So at this point, we should look at this and ask, hey, is this factorable? Can I factor this? Well, in this case, yes, you can factor this into x minus 5 times x minus 1 equals 0. And due to the zero product property, our x's will be 5 and 1. And we got 5 and 1 by setting x minus 5 equal to 0 and x minus 1 equal to 0 separately. So you might be asking yourself, hey, am I done? Well, no, you're not yet. We need to find the outcomes for these x's by plugging them into an initial equation. So I will use the linear equation, because it's easier to use than the quadratic. So here I will be showing my work for that. So I will first use 5 to substitute x. So y equals 2 times 5 plus 3 will simplify to y equals 10 plus 3, and y will equal 13. Now I will use x equals 1. So y equals 2 times 1 plus 3, and y equals 2 plus 3, and that will equal y equals 5. So our results are 5, 13, and 1, 5. So what are these numbers? Why are they important? Well, why do I need to know these? Well, actually, these are our intersecting points that we just solved algebraically. Now we need to solve graphically, but we will keep these points here as references. So let's start solving graphically. So when solving graphically, we kind of need a graph. So here's our graph, and I know it's offset a bit, but that is because we need to plot two graphs onto this plane. So let's start off with our quadratic function. And like I said, it is in vertex form, so there is an a, h, and k. And so what is a, h, and k? Well, a, h, and k are manipulate the quadratic equation. Excuse me. So a tells us if the parabola is going to face up or down, and it tells us if the parabola is going to be compressed or stretched. Now h relates to the vertex on the x-axis, and I have a little note here that says opposite because when plotting h we must plot the opposite of h. So here we have -2, but if we plotted h it would be +2. So here, moving on, here's k, and k also relates to the vertex but on the y-axis. So let's graph this. So our first question that we ask ourselves is, what is the vertex? So we will look at h and k for this. So let's plot h first. So h is -2, but we have to plot the opposite. So we will plot +2. Here's the +2. Next, we will plot k, but this will shift h up or down on the y-axis. So this will shift the h up 4 spaces because k is +4. So our vertex is 2, 4. So our next question is, will our parabola face up or down? Well, we look at a for this. So our a's value is a +1, so it will be facing upwards. Now, our last question before sketching out our parabola is, will our parabola be compressed or stretched? Well, looking at our a again, it is a +1, so it will neither be compressed nor stretched. It would be right in the middle. But if our a's absolute value was less than 1, then it would definitely be compressed. And if our a's absolute value was over 1, then it would be stretched. So here is our parabola, and as you can tell, it is neither compressed nor stretched. It's right in the middle, and here's our vertex of 2, 4. So now let's graph 2x plus 3, our linear function. So this is much easier to graph than a quadratic function. We just need to find our y-intercept and our slope. So our y-intercept is b, that is our starting point, so we will plot a red dot here on b. So our slope is rise over run, which is 2 over 1, so we will move our second place up 2 and then over 1. So now we have our linear function on our graph. So our next step is to find the points of intersection. Now we already found them algebraically up here, but now we need to use a graph to find the points of intersection. So here you can see that there are 2 points of intersection. There are 2 points where the graphs cross each other. So there's one point, and here's the other point. Now, where are these points? Let's give them names. So this point here is at 1, 5, and this point here is at 5, 13. Well, wait, didn't we get that when we solved this algebraically? Well, we did actually. So that means that we did our math correctly. So our answer is 5, 13 and 1, 5. And to check this, you can plug this back into the initial equations. Well, why is this important besides getting the right answer? Well, intersecting lines are everywhere around you, which means intersecting points are everywhere around you also. Take skeet shooters, for example. As the clay discs fly in the air, skeet shooters must shoot them down, aiming for that point of intersection between the bullet and the clay disc. This concludes my video on solving systems. I hope you enjoyed. Thank you.